Concentration is a way of reporting how much material is dissolved in a solution. There are a number of different ways in which concentration can be represented. The first is mass percentage, that is, the mass of an individual component divided by the total mass present. The second is parts per million, and third, parts per billion. These are both similar to mass percentage, except rather than multiplying by 100%, we multiply by 10 to the 6th for parts per million and 10 to the 9th for parts per billion. We use ppm and ppb both in medicine and water quality because it's a relatively straightforward idea. If you have 5 parts per million lead, that means you have 5 lead atoms for every 1 million present. Or if you have 7 ppb iron, you have 7 parts of iron or 7 iron atoms for every 1 billion atoms present. Both mass percentage, ppm, and ppb can be seen in this table here. This is a typical water quality analysis, and it reports how much material is dissolved in your local drinking water. Now, to get a little more technical, because we're chemists, we like to work with moles. And so we have 2 ways of talking about moles of material dissolved in solution. That is molarity, which is moles of something divided by liters, and is represented with a capital M. Or we have molality, which is represented with a lowercase m, which is simply moles per kilogram of solvent. Molarity is used because chemists often work with volumes, and molality is used when we work with solutions, but we're going to have temperature changes. Because density changes with temperature, molality is often used when we have high thermal fluctuation in our experiments.